Calculus Integral Review by Angie, Connie, and me. Basic concepts and vocab. We are going to cover the following topics: area between two curves, volume of cross sections, volume of rotation disk method, volume of rotation washer method, displacement, total distance traveled, position, velocity, and acceleration. The first one, area between two curves, is the region bounded by the graphs of two functions. When it relates to dx, it is the integral of upper function minus lower function from a to b. When it relates to dy, it is the integral of right function minus left function from d to c. If we want to find the area of this small triangle, which is the integral of the function of blue line minus the function of red line from x1 to x2. The second one, volume of cross sections. Cross sections add up together to form a shape, which has volume. In these two formulas, ax is the function of area we are going to use. It is the integral of the function of area from a to b. The third one, volume of rotation disk method. A solid revolution that forms a disk-like shape. It must form a radius that rotates around to form a disk. The area is equal to pi r squared, and when we plug in that into the integral equation, we get the final formula. Volume of rotation washer method, a solid revolution that's formed by two functions, which creates an outer circle and an inner circle. We need to subtract the inner radius from the outer radius when calculating the volume. This is the area equation for the washer disk. And if we want to find the volume, just plug into the integral equation and get the final formula.
The displacement is the change in velocity over change in time, which is also known as the net distance traveled by the object. And the calculation of the displacement is the integral from a to b and the velocity function in dt. The velocity function is also the first derivative of the position function of the object. And the total distance is the absolute value of displacement adding up, which means it's all the distance traveled by the object, and we don't count to the left or to the right. It's everything. And the distance traveled by the object, it should be the integral from a to b and the absolute value of the velocity function. In the relationship between the position, velocity, and acceleration is the first derivative of the position function xt is velocity vt. The derivative of the velocity function vt is acceleration at, or the second derivative of the position function is also the acceleration function.
Below is the questions we are going to cover in this section. So, Connie, I know how to find the area between two curves, but I'm wondering, can this answer ever be negative? What does it mean if it is?
Oh, so the area can never be negative because area cannot be negative. Well, if you get a negative answer, this probably means that you subtract the function oppositely, such as you subtract the upper function from the lower function instead of subtract the lower one from the upper one. Therefore, you will get a negative answer, but you should never get a negative answer for area.
Oh.
For different shapes of the cross-section, we have different formulas to calculate them. For the square, it's just the integral from a to b and y squared dx. Y squared basically means the side square, and y equals the side length. For equilateral triangle, it's the square root of 3 over 4 from a to b and the side square. For isosceles right triangle with leg on the base, is half of the integral from a to b and side square. Semicircle is the pi over a to b on side square. Rectangle, it's from a to b and side length times the height of the rectangle dx. And a quarter circle equals the pi over 4 integral from a to b and the side length square.
When do you use the disk method versus the washer method for volumes of rotation.
Disk method is used when one radius is rotating to form a solid revolution, which forms a disk-like shape. And the washer method is used when the solid revolution forms an outer radius and an inner radius. So when you're calculating the volume of the rotation, you have to subtract the inner one from the outer one, which you get the volume of the shape. When do you use the total distance traveled equation versus net distance or displacement? What keywords would signal this to you?
Total distance travel equation is used when we need to calculate the absolute value of velocity, which means the sum of the entire path that the particle has traveled. Net distance or displacement is used to calculate the distances to the right, subtract the distance to the left, or the net distance, which is the change in velocity over change in time.
Sample question 1. For number A, we're looking for the area of R. It is bounded area by two graphs, which is use upper function minus lower function. Upper function is y equals 6, and lower function is y equals 4 ln of 3 minus x. Then we use a function to plug in number and get the answer. Number B, we're looking for the volume of solid generated when R is revolving about the horizontal line of y equals 8. It is a washer method, so the outer radius is 8 minus 4 ln of 3 minus x. The inner radius is 8 minus 6. Then we plug in number to the function and get the answer. Number C, we're looking for the region R is base of a solid. For this solid, each cross-section perpendicular to x-axis is a square. Find the volume of this solid. It is the volume of cross-section. The formula of area is s squared. Then we plug in number and get the answer. Sample question 6. Number A. Find out time t during which particle r is moving to the right. When velocity is positive, the particle moves to the right, and derivative of position function is a velocity. So after we figuring out the function of velocity and set it to 0, the solution is used to create a number line. And then we plug in number to see which region is positive. Thus, for t greater than 0, less than 1, and t greater than 3, less than 6, the particle is moving to the right. Number B. Find out time t during which two particles travel in opposite direction. When traveling in opposite direction, velocity has opposite signs. After we're figuring out the velocity function for both particles, and then we create a number line to compare in which region they have opposite sign. The solution of it is for t less than 1 and greater than 0, t less than 4 and greater than 3, two particles traveling in opposite direction.
Displacement of p is the integral of the velocity from 0 to 6. Total distance is the absolute value of the integral of velocity from 0 to 6.